Da-da-da, we are back. It's episode 4. Today we're talking forecasting. I look a little fuzzy on camera. Perhaps more sleep is in order. Okay. Hey, we're going to talk about forecasting, and just to remind everyone of some of the absurdities we'll see. The famous comic George Carlin, who many of you may have only seen on YouTube. He passed away a few years ago. He used to have a routine called Al Sleet, the Hippy Dippy Weatherman. And his forecast for the weather tonight, dark. Dark with patches of widely scattered light toward morning. Yes. Okay. So we'll talk about forecasting today. Before we do that, what's going on? Career Fair is here. Wednesday, 1 February. The good folks from Cummins have been hanging out in the lobby, reading resumes, get your resume checked out, find out. You don't want someone like me pointing out, you sent me a resume and you spelled words wrong. Because me, at least, I'll tell you, the other people will just throw it out. Of course, as I'm telling you, I might point out that they have these features now. For a long time, they're called spell check. Okay, the career fair's tomorrow in Corbett Center. Don't mix it up with those people. Don't do anything other than act your age, not your shoe size, as the joke goes. I have to remind people all the time, because once in a while somebody shows up there and they're wearing shorts. It's a little cold for shorts, but I've still seen a few people. And then somehow the complaint trail ends up in my office, and I have to listen to it, and if I have to listen to it, you know how the rest of this story ends, right? So dress appropriately, look the part. If you're wondering what appropriate is, the term business casual works. If you're wearing a suit, guys, make sure your pants are the right length. You don't stack suit pants like you stack jeans with cowboy boots. Get them altered, etc. Make sure your tie's where it's supposed to be. What's really funny is a couple of years ago, some recruiter went ballistic and told the dean that people weren't behaving right and stuff like that, and we had to listen to a lecture, and I said, you know, not many people going to be attending class around me and not hear what they're supposed to do. And so I don't want to hear about it. And it turned out it was some freshman class got forced to attend or something. They decided to make the point by doing what people do when they're 18. But yeah, it's always entertaining. Career fair. Because the outbrief is always excellent. Somebody comes in and said, I tried to interview with company X and they won't hire me. Why did I choose this major? And I say, geez, there's only like 8,000 other companies that hire IEs. Maybe you could work for one of them. And that conversation, you can imagine, is never enheartening. So you have to say that. And I said, go get a job with, you know, whomever. Actually, Cummins, I think, is not attending actually the career fair, but they did volunteer a couple people to read resumes. So check it out. So, as part of our survey of all the things you ever need to know to run a productive facility, we're going to talk about quantitative forecasting today. The goal is how to predict what we need so we can be ready. How cool is that? Fortunately, for those of you who are math fans, you can throw as much math at this problem as you want, and you still end up making a what? Decision. That could be wrong. But it's a good idea to be ready. And to illustrate a forecasting problem, I share the following data, which looks a little small. I should have printed it bigger. Thank you. We're on class number 4. For those of you who are in internet land, what I do in the morning before class is make copies of the handouts. I make them 4 on a page to save money on paper. Since I also pay the bills for the paper, I'm conscious of that, all right? So there were about 20 people registered on the first day, and I didn't keep records after that till today. There are 25 people in the on-campus sections, okay? Now, most people who register for the on-campus section choose to time shift their viewing of class, despite my recommendation that they attend class, because if I know who you are, you might benefit, but they do that. The first day I made 20 copies and I had one original, so I usually staple the original and throw it in. It looks the same as the copies, so no one could tell. This was the original. Perhaps I could sign that one, right? We can auction it off someday. We'll be on Antiques Roadshow 20 years from now. Wow. Okay, so the second day, given that there was 0 left over, the second day I made 21, and I discovered there were 8 left over that I had to toss out. Delta was 13. The next time, of course, as the semester settles in, there were 12 left over, leaving me some to toss, right? 12 to toss. Today I made 10. And judging by the size of the in-studio audience, it was a good decision. Since at the end of class, since some people start times are flexible, may show up a little later, that kind of thing, right? So at the end of class, I count. Now, why am I doing this? Every next period, I'm doing what the chapter calls a 1 period ahead forecast. How many copies to make? Now, of course, the more philosophically inclined out there would say, geez, why don't you loosen the vice grip on your wallet and just make 20 copies and throw out the ones people don't take? Certainly a business strategy, correct? Is it a good one? Answer, obviously I don't think so. Why? I got to pay for the paper, and I got to pay for the copies. What would I rather do? Use that money on something I'm not going to throw out, correct? Hence forecasting. Also, I have to spend time making them, right? While I'm making them, I'm interfering with people like Dr. Sohn who send printouts to the copier because we have a network-enabled copier. Now, again, you all say, oh, big deal, who cares? Well, yeah, at this level, it's not that big a deal. But think about it differently. Suppose you are sitting in the airport. I was in Miami International a couple of months ago, waiting for a flight to Dallas. And there was a dent on the skin of the plane that had to be inspected. And one of the possible ramifications of this was that the flight would not take off. And you're thinking, hey, why doesn't American Airlines roll in another plane? That sounds exactly like my problem here, right? Just roll in another plane. That is a more expensive problem, right? American Airlines probably can't afford to roll in another plane. I would bet they don't even have an extra in some cases, because it would have to be where? In Miami. And to add insult to injury, guess what day this happened to be? The Wednesday of which Thanksgiving was the following day. So you could imagine what that airport looked like. Plane took off 2 hours late. I had run across DFW, big deal, right? But, again, what's happening? Plane's there. Everything looked cool until somebody noticed, hey, there's a big dent in the plane, big enough that it has to get checked out. So that's exactly the same problem. How do you forecast usage of planes and so forth? Get people from place A to place B and so on and so forth. So it's easy to talk about with copies for class, right? Solving American Airlines is maybe next class. Well, actually, if I really could solve all of those problems, would I be sitting here teaching this class? Answer, tough call, right? Okay. So the most basic model, we're modeling demand. Uh-oh. Thank you. Gotta see what happens. You change fonts and doesn't autofocus out there. We want to model demand for whatever it is we do. For example, aircraft. Demand is a response to something. If we think about this, what's a little counterintuitive is time is the independent variable in the simplest model. Because who controls time? No one. It just keeps running. But fundamentally, our model looks like this. Demand is a function of the mean plus an error term. Now, if you want an example of error, consider my copies. If I make 10 and 14 people show up, then I made an error of size 4. Alternatively, if 6 people show up, I got a different error. You know, you just pick whichever you want to be plus and minus. Notice no term in the equation for trend, cycles, anything like that. So, in any event, what we would do is, noting that many of you would prefer not to write, refer you to page 62 of the textbook, which has all the equations for these things and notation. Forecast error is really important. It's usually seen as an absolute error or a mean square error. If we square terms, then we're always positive, right? Yes? Good. It's kind of like those negative probabilities. It's just not good for your grades. Okay, so page 62 has the notation, and they use the expression one step ahead. One step ahead means the next data point. So for example, on Tuesday morning or Thursday morning this week, I will forecast the number of copies to make and make them. That's a one step ahead forecast. Now when I do this with the mean, I can have your standard issue Our standard issue mean is add up all the x's and divide by the number, right? Or we could do a moving average, which allows me to do what? Take a look at more recent terms and drop off older terms. So if I have x1 from up to week 47, do I really care what happened in week 1? Do I want that to help me predict something? And the answer is, it all depends. One of the beauties of doing this is you're in charge. You could use a regular mean, or you could use a moving average. And basically, if I do a moving average, you got a lot of notation, but fundamentally, if I'm doing a 3-period moving average in September, I'm forecasting September, then I get the average of June, July, and August, and divide by 3. Pretty straightforward, right? The logic there is more recent events get more what? Weight. This works well if what? If things are building up or slowing down, right? Because what it does is toss the older data points and give emphasis to the new ones. And somehow you need to call out the length of the moving average. Now, if you happen to have your textbook open, then on some of these problems, they have moving averages. Page 67 has some. We might, if we get time, look at some of the problems on page 69 today. Pretty straightforward. June, July, August, divide by 3 or something like that. Now, another way of looking at this sort of basic thing is called exponential smoothing. And when we do exponential smoothing, this is simple and popular. You have a weighting function. And as they say, it goes to page 74. They have some explanations. This being an MBA textbook, it's oriented towards MBA programs. They're definitely long on explanation compared to engineering books that have mostly sentences like, it is left to the reader as an exercise to prove. You know, what? Okay. So in any event, you can read that. We'll work through an example in a minute. But fundamentally, what you do is pick a weight of how you are dealing with things. And fundamentally, what we might do is something like this. This is the basic exponential smoothing model. This is the current, we'll call it observation. And this is the last forecast. What this does is allow us to give some weight to the forecast and the current observation each. If you like, you can make it 50-50. Or you could 0.1, 0.3, somewhere in there. It varies quite a bit. We use it when we're using a basic mean type model. But fundamentally, what are we doing here? We're giving some weight to the forecast, and we're giving some weight to the most recent observation. Imagine, if you will, the following. Some event occurs. It changes the way people demand items. Do these things happen? Sure, every day, right? And given the relative emotion level of politics right now, we'll keep out of that. But imagine, if you will, some consumer product. You discover that, I don't know, Tom Brady uses it. You want to buy it. Lots of people want to buy it. Suddenly, demand goes up, right? Conversely, let's see. A good example of a consumer product for which demand has changed recently in the last few years is little NFL beanies, such as modeled by the players on the sidelines in the cold. I happen to have one in my gym bag. Going to the gym tonight, it's a little cool when I get out, so I have one of those little acrylic NFL beanies. People have seen me wearing some and get nervous. I have a picture of me wearing a beanie that I took coming out of the gym, and it's unnerved a few people. I said, why? I don't go to the gym. But in any event, some years ago, those things didn't exist. Not that long ago, you didn't see people wearing them. In fact, like, I played with people whose coaches wouldn't let them wear beanies under helmets in the cold and things like. This was unmanly, or you couldn't hear, God only knows. It's medieval times, right? But now they're quite popular. The demand pattern for them has changed dramatically. It's a consumer product. All you need to do is have somebody seen wearing it, and the demand will spike. So it might be useful to do a little what happened recently kind of thing. Or, for example, yeah, the beanies are great. If one of the Kardashians wears something, change the demand pattern quite dramatically. And the demand pattern for alternatives that are affordable, right? Because there'll be a website that will mention, if you can't afford the original, you can get this at store X and look almost like, right? Okay, so to make this even more mundane, some years ago I invented an example with people using up boxes of fries. Nice product. Of course, the nutrition police will be after me, right? This is not a low-carb, low-fat product, right? It's just boxes of fries. No one ate them. I made up the numbers. Okay, so don't write in and say, how can you use that? That's disgusting. Okay, so period 1, they used 1 box. Period 2, 2, 3. I got more imaginative. 5, 8, 7, 4. Went down. Can it do that? Sure. And then suddenly we had a promotion or something, right? We used up more. Now, the first thing I tell everyone to do before you do anything about forecasting is just plot it. Now, you might think, geez, a lot of seniors and grad students in here, but you'd be surprised at how many people don't think to just plot the data. And given that you can do that without a pencil and graph paper, right? What does this look like? Looks like it's going up pretty continuously, right? These must be great fries. Now, we can actually fit an exponential smoothing model. I did it in Minitab. You can do it. I have a spreadsheet that does it in for these data in Excel that I'll put on Canvas when I remember. Minitab does it, SAS does it. You can do it in, God, any software imaginable that does data, MATLAB, and so forth. But I used a smoothing constant, or alpha, of 0.2 to do this example. Original data, forecast data. Oddly, what it did was start higher, go down, and go sort of up. It didn't go up fast enough, though, did it? If you used this model, what would happen? You would be out of stock, correct? And what would happen to you? Maybe nothing. Maybe you'd go out of business. Maybe people would make reservations to get fries. It's a simple example, in other words. But if you have a stock out, imagine the following problem. Say instead of boxes of fries, this was, say, Super Bowl champion t-shirts. Is stock out a problem on that one? Not really. Because the people who buy those things will be just as happy to get them in March, right, after you reorder. On the other hand, could they walk away and instead start thinking baseball? Yes. So granted, it's with the box of fries, you think so people go to another restaurant, right? Except for one thing. If they get in the habit of leaving your restaurant and going to someone else's, they might continue that habit. You would lose customers. Some mildly computer-savvy person with an iPhone would say on Yelp, you guys are always out of stock, and you would get a reputation for not meeting customer demand. That would be bad. How could we fix this? We could say, do what? Eventually look at this error term and say what's acceptable. We could put, as I'll mention in a minute, a tracker in here to look for, should we adjust our forecast? That might be useful given this pattern, right? Or we might look for what's really driving that thing and will it continue? Now what the data actually look like is on the next page. And this shows you what the prediction would be. We sold one, we predicted whatever. Here where we have 10, we predicted 5. That's not good, correct? Minor detail, it happens every day. I needed this, I have that. At the level of box of fries, this seems sort of like not that exciting, right? You say, well, Dr. Science, why don't you change your forecast, right? And the answer is, of course, what evidence do I have to do that other than some wise guy popping off, right? The answer is I could experiment with a different smoothing constant to account for the increase over time. Or the other answer would be, is there actually not just a mean here, but a trend, right? See that guy take off like that. There's obviously a trend in these data that I'm not accounting for, hence a big error. Nonetheless, just to satisfy everyone, I created a second model with a smoothing constant of 0.5. And you can see that this is tracking much nicer because the 0.5 helps account for the trend. Because taking 50% of the last observation and 50% of the history is helpful if you've got a sudden trend in one direction or another. Now, the recommended approach would not be to account for it with a smoothing constant, but to look for what's causing the trend and attempt to model that, as we'll see. But this is a much better fit, isn't it? So that's exponential smoothing. And when we talk about that, again, the basic level of doing this is the mean plus the error term. And could we do exponential smoothing with trends? Sure. As soon as we identify a trend term in there, we could do that. Not a problem. Get one of our intrepid faculty that's into modeling these things, they'd have it for you in a snap. Not a problem. You'd spend more time explaining to them when you needed the answer, right? They'd have it for you in no time. In fact, I could too. We can also do a regression type of fit on the data, and that's just fitting a line or a curve, get some data, fit a model. What would my model be? It would depend on my data. Run a regression model, you can fit actually a pretty good line. R squared of 0.855. That would be fantastic with experimental data. It's real significant. It would be great. Fantastic. What's it going to look like? Let's start down here below the intercept, right? In the negative boxes of fries, which we won't consider. We just have to fit the line, not make it. You could start here if you like at 0, and it would go like that. Be a pretty good model. And in the best traditions of running Minitab, we could do a normal plot of the residuals. Again, nice line. Pretty good gig, huh? Man, that guy who invented those data knew what he was doing, huh? It's a beautiful thing. What am I really showing? Think about it this way. It's some function of time, right? And in fact, what did we get? We got by hat, keep our notation clean. So if I were running my little restaurant in week, I don't know, what did we have, 15 weeks of data or whatever, 14 weeks of data. So if we were looking at week 20, we could predict away. Order boxes of fries and do what? You say. Ask ourselves the obvious question. One, can we actually do that? The answer is, what do you do? Now, what makes this not an ie460 or any experimental methods class problem is these questions, right? If my model says next week I will produce 40 boxes of fries, am I equipped to actually do that? Might be a reasonable question. Do I have enough people? I don't know, however you make these fries. Do you have enough fryers? Enough plates, enough boxes, whatever you serve in? And do we have the money to do something with it? If I got to make 40 boxes of fries, and to do that I need 2 more people working for me, for example, do I have the money to pay them? Get them trained and so forth, right? I mean, looking at that model, you would say, geez, it's a big deal. This seems pretty straightforward. And the answer is, of course it is, as long as you don't have to implement anything. If you have to implement something, you end up on my end of the industrial engineering business instead of the math modeling end. Because now, if you think about it, if I need to expand my kitchen to support additional customers, that's not a short-term decision, is it? And do I have the money to do that? Do I have the interest even? Or should I just top it off at 40 boxes a week or something like that? Not only that, how do I do what? Actually get that done in time to do the thing. Should I be looking at it a week from now if I'm thinking about kitchen expansion? Answer, no. Should have been thinking about that 3 years ago or 2 years ago or something. A year ago, whatever. So we go back to short-term, long-term type thinking. What can I do in the short run? What can I do in the longer term? Good example of the capacity problem is staffing an academic department. In the short run, what do? If we need an extra section of Class X taught, hire some adjunct faculty member, right? If I do that, I bring with it certain aggravations and things, some of which you guys experience, some of which someone like me experiences. For example, adjuncts don't necessarily hang around after class. A lot of students like that, right? Adjuncts don't get involved in campus life potentially. Adjuncts do. They don't have the same loyalties and so on and so forth, right? Now, if you're taking, say, I don't know, tech writing, maybe you don't care. But if it's a class you're really interested in, you might care a lot, and you might be a dissatisfied customer and so forth. Now, alternatively, if I knew in advance I would need more people, I could do what? Budget and hire. I could convince the dean, for example, the IE department should have 12 faculty. Then I have a different problem. If you're familiar with upstairs, I don't have 12 offices. So what do I have to do? Well, all you GA guys that have those offices, where are you now? Out. In trailers somewhere or something, right? And now we have a different group that's unhappy, right? More cost. Correct? Now, the real problem is what happens if we do all this and it doesn't pan out. Now what? You have a lot of money and time committed. You could potentially lose everything, right? So the correct answer is that you don't necessarily bet the ranch and the dog on every forecast. You have to look at the track record of the forecaster and so on and so forth. But fundamentally, what makes this into an IE-type problem is these questions. And what are the ramifications of each decision? If we do this, then what will we not do? And that's another interesting problem. What don't we do because we made a decision? The classic fun example will occur this Sunday evening. After the Super Bowl, whichever team wins will be seen wearing a bunch of sort of gaudy baseball caps and T-shirts, right? That will say Super Bowl champs. They'll have the team logo and all that, right? Now, you don't really think there's a factory under the stadium that all of a sudden produces a whole bunch of T-shirts, right? What do? They incur the cost of printing them up for both teams. And then what do they do with the ones that don't work? Dump them somewhere. Why can they do that? Look at the cash flow in the NFL. They can afford that. Not only that, what do? it's a money shot, right? Somebody, as they say, that's the shot you want to see, is the star of the game wearing a goofy-looking ball cap that says Super Bowl champs, right? You might buy one yourself for all I know. And actually, I won't think they're goofy, but I'm not buying one. Nonetheless, what have they given up to do that? They've paid for 2 sets of outfits. That's worth it to them, though, because they can do that. It's a money shot to have those shots, right? Guys in the locker room, stupid behavior, everyone loves that. Well, not everyone, but enough people, right? So think about it. Any of these things, if you want to have the stuff available immediately, you can do it. You just have to do what? Accept the cost of immediacy. Now, one of the interesting things, I've been following the sports apparel business for a while now, teaching these classes, because it's a popular product. It happened that the school I went to has won a number of championships in various sports, none of which had teams I played on, right? I did nothing, I cheerfully admit. The evening of the championship victory, I kid you not, there was an ad on Facebook and in my email saying, get your Big Ten champs shirt apparel. That you can slow down a little on, because why? Because the championship doesn't go away till a year from now, right? So it takes a week or two, big deal, right? But like, say, if you want a good example of a forecasting problem, consider something like the, what do they call this? The wild card games. Like somebody was champion of the Western Conference or something, right? And then they played in the wild card game, you could buy a shirt. Except by the time you got the shirt, the game was over. They may have gotten clobbered according to this season, right? Because a lot of the teams lost big. That could be a more chancy kind of forecasting. So just some examples. Now, if you're, for example, the United States Army, as some of our internet viewers are members of, their forecasting problems are both immediate and long-term. They can't very well say, wait till we gear up, can they? Now, of course, if you're a student of history, you know that there were occurrences where that did happen, but not these days. So they have to schedule differently. So the question is, why is time useful then, if there are so many other things? And the answer is, things do grow, and they contract as well. It's the one thing we have data. We might not know what's causing people to do something. Now, one of our alums is CEO of the Girl Scouts. This is true. I didn't make this up. And right about now, her Twitter feed is featuring what? Would you think? Besides the usual messages about the greatness of scouting for young women, What is it the season for? Not a lot of parents in here. Girl Scout cookies. That's a great forecasting problem. Girl Scout cookies get sold over a short period, and once they're gone, right? When do people buy Girl Scout cookies? When the Scouts sell them, right? I don't know exactly when, but I know that I've been getting tweets that emphasize the importance of eating Girl Scout cookies and the value of them and so forth. A lot of them look pretty tasty. They're also what? Not exactly the healthiest things, but they're tasty. Gotta admit, some of those Samoas are really good. The Thin Mints are universally popular, correct? There's a lemon cookie that I used to get that was pretty good too. I have to find out who in the IE office is a Girl Scout leader and then check into them, right? But Girl Scout cookies would be a good example of forecasting. How many do you bake? You can't keep them till next year, right? That's probably a more sophisticated model, but they would be interested in the last few years we sold X boxes of Thin Mints. We produced Y. What's the error there? Should we back off on Thin Mints because now we have whatever new cookie came out? Typically what forecasters do is install tracking signals. When do we find out the forecast is going kerblooey on us? If you took quality control, you would remember the various runs rules that help us determine we should go investigate something. Same thing here. What do you have to do in advance? Well, like most things, hindsight is always 20/20, so you don't get the benefit of that one. You got to say in advance what you're willing to accept as an error, and accept that the cost of that error is built into the cost of your product, potentially. Let's say, like, if you make a couple of million more boxes of cookies than you can sell, you'd kind of like to know that before you have a couple million boxes left over, so you could encourage greater vigor or whatever they do. I'm not completely familiar with the sales tactics, other than I've generally have seen the kids out in front of like Albertsons and Walmart and those kind of places selling the cookies. So there's a lot of methods in the chapter. They discuss some. We'll talk about some when we work some examples. But essentially, what do you want to do? The data are telling me one thing, reality is telling me another. What should I do? Answer, highly situational. What should I do? Another method people use, and we'll talk about briefly, is what's called an ARIMA time series for autoregressive with an integrated moving average. When I was a grad student, they had a whole course in this. They probably have more than one course. I just knew it. I took the one course, and that was like all I wanted. My friend, who was much better with statistics, loved it. So, but essentially our forecast has two components. One is a regression model to relate the points. The other is our old friend, the moving average. So typically an autoregressive thing you do on a computer, you wouldn't waste time doing this by hand. It's easy to do. Dr. Box, famous statistician, is the same Box from quality control textbooks and statistics textbooks. Really a prolific guy. Done a lot of stuff that people use. Let's take a look at an example just of a moving average for a few minutes, and that is on page 69. In this class, if I write MA, it means moving average. Surprise, right? Just in case somebody, what does he mean by that? He's been talking about moving average, but that could mean something else, right? If I have data for some part, and that's what's on page 69 here, and it asks me the forecast for, obviously if the book were more up to date, no one would have the opportunity to say, why are we forecasting that? Don't we know? Okay, so a three-step moving average would be 275 plus 188 plus 312 over 3. And if you wanted a six-step moving average, you would just add 3 months more to that, and so forth. So you would get whatever, let me see, calculate it. On camera, I always try not to do these on camera, but I forgot the solution. Which I did, by the way. It should be 258.33. Which would be okay if what? If the last 3 months were predictive of January. Example of what wouldn't be. Imagine you ran a warehouse that filled orders for apparel. Golf clothes, for example, like polo shirts. Your warehouse was filling orders with some enthusiasm into November, possibly into December, right? Why? It's the Christmas season. People are buying presents. End of the year, that kind of thing, right? How many workers should you have in January? Now you have a problem. What are you doing in January? Is the last 3 months predictive of that, right? Another thing that's interesting is in January, people tend to put the last season stuff on sale. Some of you might say, hey, now is the time to upgrade, right? I can get the $125 golf shirt for $57.50. Ding, 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 ding. Another order, right? Now you might need different levels of personnel, right? Going to have a sale. Alternatively, you could do nothing of that type and keep the warehouse level. What is that? That's a management strategy. You can decide what you want to do. And you will either be potentially right or potentially wrong. And what will tell us is the result at the end of the year. We keep score with money. If you lost a lot of money, then you guessed wrong. Or you made an error or something. Now, I'm just sort of proposing possible solutions because this is pretty simplistic, right? If you're actually working there, you know what's going on, and you could potentially still be wrong or right. Want another good example? How much for the students who are from oil-producing regions like Texas and Southwest Asia and North Dakota now, right? How many rigs are in business is a metric people look at. That might surprise you, but that number is reported quite extensively. So there are all sorts of things. Using things like boxes of fries and parts are useful so that everybody gets the picture, right? Okay, so in any event, it also asks you some interesting things like using a 4-month moving average, what's the one step ahead forecast for July through December? Could you do that? Sure. If I'm in July, June, May, April, March, divide it by 4, that's my forecast for July. Alternatively, you could do what they call a 2-step ahead forecast. Now, a 2-step ahead forecast, as they point out in the hint, is July is based on observed demand in February through May. So I take February, March, April, and May, divide it by 4, it gives me my forecast. So, for example, a 1-step ahead forecast for July, which is The actual was 223. Now what? You get an error. If you do a one-step on July, for a 4-month moving average, you have June plus May plus April plus March over 4, 205.5. Alternatively, February through April, or May, rather. February through May, divide that by 4. You get that. Now, if you do your business based on this forecast, not so good. Here, not so good either. What does this mean? Well, it could mean what? That 17.5 people don't get their parts. Now, really, would you order 205.5? Answer, no. As we'll find out as we go through the semester, nobody's, except on something very expensive, nobody's going to order exactly what the forecast says. You order in different order strategies. But in this case, you forecasted 205.5. Your actual experience was 223. Answer is you have roughly 17 people who didn't get what they wanted. Alternatively, in this case, you'd have 80 people who didn't get what they wanted. And that's 80 sales you lost, or 17 sales you lost, or back orders that you had to carry. And that's not so good either. What would be the next thing to do? Well, find a better forecast. Because realistically, you know, if we were making a sitcom, there would be some character in a cubicle who would get their head handed to them, right? You nitwit, he could be played by, for example, the guy that played the King of Queens, right? He plays those parts where everyone calls him, right? If we were in a sitcom, we could have some guy in a cubicle and we'd all yell at him and it would be funny. In real life, this is not funny. This is a whole bunch of orders you lost, right? Maybe we need to help this individual come up with a better forecast, right? But fundamentally, at this level, what we're thinking about is the idea that a forecast is a good idea, and let's see if we can do a better job. Not, like I say, make a sitcom where we just yell at someone and everyone laughs, lots of laugh track. It's not fun to play that role in real life. Having somebody ranting at you on the phone isn't funny. So what we're going to be thinking about is the idea of how would we get a better forecast. But just to show you something with numbers, this is great, because you see that the error is real. It's not just you missed the target. It's like I said, 80 people didn't get their part. It's 80 people have a reason to find another vendor. That's not good. Alternatively, if you have 80 more than you needed, you're paying for those until you sell them. We are, once again, out of time. I'll see you all Thursday. Get a job tomorrow, everyone. Have a good day.